not that Corey. I'm not that Corey either. I am the other Corey. I'm also known as Bantic. I've been Bantic since before I got online. I was also the Reverend Dr. Corey Bantic, and if you read 2600, I was the Reverend Dr. Jackal-Headed God. I'm talking to you today about an oxymoron. No, I'm talking to you today about business intelligence. Business intelligence, which is basically the process of, as Jesse Tron put it, taking data and turning it into information. By the way, I want to thank the organizers for making me go after Jesse Tron. I really, thank you so much, so much. So, I'm a developer with a long memory and a longer history. I'm not going to say how long I've been doing this. I'm an active open source contributor. I'll talk about, plug, otherwise promote some of my gems a little later in the presentation. As you can tell, I care deeply about fashion. So what I do is I work for a men's fashion startup. Yes, I'm serious. And I'm a lifelong learner. Serious about the latter part, not the former part. So I work for a company called Trunk Club. We are a service-oriented startup. We're not an e-commerce company. The basic way it works is this. You're a guy, you want to look good, you have no idea how. So you sign up for our service, we connect you with a stylist who asks you a series of questions, figures out what you would look good in, sends you a trunk full of clothes, you keep what you want, you return what you don't, at which point we bill you. A lot of money. In December, we had $2 million in revenue. Last month, we did $3 million in revenue. We're doing okay. So because we're not selling things directly, we're not ever putting a price tag on a pair of $200, $300 jeans. We're selling our service. So what technology does in our business is it optimizes the service delivery. We like to say we're trying to take our sales force and make them bionic. Engineering provides leverage for scaling up the business. So our goals, basically our philosophy, is that the business has to make decisions on a daily basis. We have data, better data leads to better decision making, therefore let's get them as much data as possible in as timely and useful a form as possible. So what are the things we care about? We care about how are our marketing campaigns performing. We spend a lot of money to acquire a lead. We need to know, are we spending so much money to acquire a lead that we're not actually making any money off the guy? Where are people in the onboarding funnel, which is a fancy way of saying how far along did they go in our sign-up process before they said, screw it. The trunk life cycle. So for shipping these boxes out, getting them back, we need to know where inventory is at a given point in time. We need to know every time a stylist interacts with a customer. And we need to know how is that $300 pair of jeans performing? Are we selling a lot of it, or are people returning a lot of it? So we have a lot of questions that we're asking, and we have a lot of data. And business intelligence is about lining those two things up. So this is a hunting of the snark reference. If anybody gets this, you get 10 points. Business intelligence and 3 approaches. I apologize for the top and bottom being cut off, but I'm not going to stop. What is business intelligence? It's taking that mission critical information, collecting it, organizing it, providing an historical view, and doing decision support. So if you have to make a decision about how much money am I going to spend on Facebook today, you need to know how much did you spend yesterday and how well did you do with it. So there are 3 approaches to business intelligence. The first is the naive approach. That's the Fiji mermaid. P.T. Barnum took this monstrosity and wheeled it all around the country, made a fortune showing basically a clever piece of taxidermy. And lots of people fell for it. So the naive approach to business intelligence is, I'm going to take my transactional database, and I'm going to write some reports. And I want the reports to be faster than they're performing right now, so I'm going to go ahead and put raw SQL in my objects. And that's still not good enough, so I'm actually going to let my stakeholders access SQL directly. How many people are doing this? Be honest. How many people have done it? Learn better? Okay. So there's some shortcomings to the naive approach, and it's a life cycle thing. Everyone does this at some stage in the business. You're fighting the schema with complex joins. You're getting crappy performance, and every time the guy in accounting hits the database, your production resources go. So the short story is, don't trust that guy with your database. He's a fine fellow. He kills with Excel. He has no thing up in your secret. So when you move past that phase in your life cycle, you're like, we need an enterprise solution. So what we're going to do is we're going to take all that data that we want to report on and move it to a business intelligence database. We're going to have these scripts called ETLs, not ET, ETLs are basically extract, transform, load. Take data out of one database, transform it, load it into another database. We're going to optimize that schema for reporting. We're going to have our separate hardware and software stack, so we're not impacting production when we run reports. And reports, oh my God, you want dynamic reports, you want static reports, you want them emailed to you, you want to get them on your phone, no problem. We can do this. All it will cost us $50,000 per user. Other shortcomings, besides the $50,000 per user price tag, is that there's a 24-hour delay in information, which if you're a startup is a big deal. It's expensive to configure, it's expensive to maintain. You have to hire consultants to come in and do it for you. If you change your mind, you're screwed. It's enterprising. It is very, very enterprising. I'm not making this up. These are actual BI software products, graphs, and reports. That's Edward Tufte would be turning over his grave if he were dead. Short story, don't trust these guys with your database either. I'm sure they're nice guys. Look, they're wearing clever sandals. They're all individuals together. That's so cool. So the traditional BI approach is basically the wrong hammer. It's tightly coupled to a waterfall process of development. You do big upfront design, you write your ETLs, you design your star schema, you do all this crazy shit, and at the end you get a report. And if anything changes, you go back and you do it all over again. It's very brittle. There's no testing. And you end up with logic embedded in your data store, which is like one of those 101 mistakes that you don't want to make. In short, traditional BI feels like waterfall. It doesn't feel agile. So what's the alternative? We're not going to give our stakeholders access to the database. We're not going to bring in the blue and khaki army. Then what are we going to do? I'm glad you asked. There's something called a lightweight approach to business intelligence that I'd like to talk to you about. Basically, there are four noble goals. You want real-time access to data to support decisions. You want to leverage technology that you're already using. You want to use the people that you've already hired, and you want to be iterative and agile. In short, you want to trust your developers. So how do you get started? You start by collaborating. You as a developer cannot guess what people need to know on a daily basis. You can ask them, you can work with them, you can ask to see their secret Excel spreadsheets, and I guarantee that every person has one that actually lets them help them do their job. So figure out KPIs, which are key performance indicators. Those are the things that they're going to need 4 times a year. Every quarterly report has to have the KPIs in it. Once you have that out of the way, figure out what questions are you actually asking on a daily basis that the data that I control can answer for you. We're going to take that information, we're going to turn inferences into facts. We're going to learn how to tell a story with our data. We're going to design a schema based on those facts, and we're going to denormalize like a boss. This is one of those things where it's like jazz, you need to know the rules before you can break the rules. It is fine to denormalize. If you're in a reporting situation, it is wrong to not denormalize. So be free, denormalize, free your data. Write it 600 times if you have to. You want to make it fast on a read in a reporting system. You want your new lightweight data warehouse or business intelligence data store to be the central, single source of truth. You don't want to have to ask other systems for information. You want to have one place that you go to. And then you want to take that data and present it wherever it's needed. We saw during the lightning talk a really cool dashboard. I can tell you that dashboard design is very, very hard if you were going to get it wrong. You're going to get it wrong the second and third and fourth time. You're going to have to iterate like hell. So plan for that. Plan for collaboration. And please, guys, no. Don't do this. Don't do that. Don't do gauges. No. Yeah. So we're going to bring Ruby to the BI party. Ruby, as we all know, is a wonderful language. It helps us do wonderful things. It makes agile, test-driven development really, really easy. It makes it really easy to spin up new applications. There are lots of visualization libraries. We saw one earlier. Powerful SQL orms and NoSQL orms. I'll come back to that in a minute. And Ruby is actually great at data munging. I learned data munging back in the Stone Age with Perl. And Ruby is a wonderful, wonderful tool for data munging as well. It's no Perl, but it's great. So another tool that you can bring to the party in addition to Ruby is MongoDB, which I'm a huge proponent of. MongoDB gives you flexible schemas. You can change your mind. You don't ever have to do a migration. You can store native data types. Anything that can be serialized can be stored. Querying and aggregation is amazing. It's fast, it's performant, and it's really, really easy to scale up. So I recommend Mongo as a tool for your reporting database. Just my recommendation. From my experience, it's worked out really, really well. So that's sort of the high-level overview of what you can do by doing your BI system in Ruby. I want to share some techniques that I've learned along the way, and go ahead and try these at home. Parallel database deployment. Mongo is an upstart. NoSQL databases are upstarts. Document stores, key value stores, and so on are newcomers to our world. There's nothing wrong with using traditional SQL. I love Mongo, but we use Postgres as well. And with a modern framework like Rails, you can actually have both databases running simultaneously in the same application, hitting two different data stores with objects that actually talk to one another, and you can even build relations between them. There's nothing wrong with that. Use SQL for your transactional data. Use NoSQL for your reporting. Keep the business logic in your applications. Keep it the hell out of your database. Parallel database deployment will make your life much, much easier. Use every database technology for what it's best at. Statistical models, another tool that I sort of picked up along the way. Basically, they're collections of facts. We're used to objects with attributes and then persisting those objects and their attributes in a database. And then if you actually want to report across objects, you have to do a lot of calculations. You have to build up fetching, do a lot of math, add things up, sum it up, and spit out an answer at the end. What if you did that every time an object in your world changed and you just stored the calculation? Well, it's expensive, you say. It is. It can be. It doesn't have to be. I'll show you a way. Statistical models store those calculations for you. So whenever you want to know what was the total value of clothing that we shipped yesterday, there's a single place that I can go and find that answer immediately with no calculation at all. The data can span an object graph that is this big. We have a legacy Rails application. Our object graphs are geographic in nature. They're horrible. We're able to take derived statistical information across that graph and condense it into a single object and store that object, the collection of facts, which of course we denormalize and optimize for reporting. Here's an example of a statistical model. And this is a Mongo class, don't be alarmed. Mongo is declarative, it doesn't use a schema. You have field declarations, which essentially define your schema crazy inside your class. So these are all the stats that I want to keep about the performance of a member. Are they a customer? How many trunks a year do they buy? What's the average value of those trunks? How much stuff do they keep? When's the last time they transacted? These are all things that I could figure out. I could ask a transactional database, but it would have to work to tell me the answer. I would rather get the answer anytime the member transacts and store the calculation. Another sort of tool that you have at your disposal that I've sort of come across is what I call a streaming ETL. So I talked about the traditional monolithic enterprise-y approach to BI. You have these ETL scripts that run every night that take the data out of your transactional store and throw it into your BI warehouse. Why not, as I just said a moment ago, why not every time something changes, do those calculations and store them so that you're continuously extracting data out of your transactional store and continuously updating your statistics so that whenever you actually look at them, they're actually up to date. Then your calculations are defined in code that you actually control and can write tests around instead of in ETL scripts that are black boxes or, God forbid, in SQL. Let the data munging happen in the background. Throw a message onto a messaging queue and have your lightweight BI system listen to that messaging queue and update the calculations in the background so that when someone comes and asks a question, it's ready with an answer. So here's one example of how to set up streaming ETL. We use RabbitMQ. I don't know if you guys use messaging yet. It is the future. Get used to it. We set up a little notifier that says, hey, I'm a model and I just changed. Anybody who wants to know about this, I'm telling you, I have changed, and here's what's changed about me. And then you have other systems that subscribe to it. And I wrote a little DSL because that's what I do. That says route a product ship message to update the product. Route a product return message to update the product. Updates product basically takes parameters that were sent to it. It either finds a product or creates a new product with those parameters and updates its stats. All this happens in the background. And here's my little product class. It has a calculator that it includes as a module, and it has all these fields that, once again, are statistics with reasonable defaults, declared in my code, not my database. And so when I initialize with params, I'm going to find the product that exists, or I'm going to create a new one, and I'm going to update its statistics. The data will be ready for me. The answers will be waiting when the question gets asked. The final tool that I've sort of learned along the way is to make everything with an API. Sometimes your API is internal. It's one class calling another class. Sometimes it's going to span systems. Sometimes it's going to go across a messaging bus. Build APIs everywhere. Provide easy access to your data because it will be used, should be used, could be used in new and novel ways that you cannot anticipate. So expose it all. This lets you quickly build dashboards and data explorers, which I will show you. And shameless plug, you can use a faceted gem to make building your APIs in Rails or Sinatra really, really easy. Yes, that's my logo for faceted, and yes, every single one of my open source projects has a logo. That's just how I am. So I want to give you some examples of what we have done at Trunk Club with our data and ways that we've answered questions about the data. First, I'm going to talk about LEVIATHAN, which basically takes every bit of data that's thrown at it and swallows it whole. LEVIATHAN is our BI repository. Here's the way our system looks. It looks really complicated. It's not. Old, new. Monolithic Rails app, Postgres database. We actually spent the money on the blue and khaki army and bought business objects for a BI system, which is horrible. We have all these satellite applications that hang off of our monolithic application, but then we wired up RabbitMQ, and now we have all these apps that are Backbone, that are Sinatra, that are lightweight Rails applications, that are headless, that are iOS, that all uses messaging queue. LEVIATHAN listens to everything. So the old legacy system calls it through a direct API call. LEVIATHAN listens to Rabbit messages, and some applications like the iOS application call it directly. Others we have to pull data out of, like periodically. So LEVIATHAN basically records not data, not objects, not states, but events. Something happened. These are the 5 things that were involved in this transaction, but this thing happened, and here's all the information about that thing. It's all stored in an event model. The event model has exactly 3 fields. A label, which is what's the name of the thing that just happened, application, where did it happen, and the details. And this is where Mongo, in my opinion, really shines. Details is a hash. It will accept any set of key value pairs that I throw at it. So whatever information was contextually relevant to the transaction, to the event that just happened, I can store in the database. And I can search across the keys looking for values that match the things I'm interested in. So if I want to know, I want to see every activity, every event related to a user named Sam with a Gmail address, I can do that. I can search across the data in that way. I don't have to guess in advance that I'm going to want first name or email domain or any of these things. It's all latent information in the data that's easily retrievable. So this is what LEVIATHAN looks like. There's a filter on the left-hand side. There's an event list on the right-hand side. That's the basic approach to it. And it defaults to stuff from today, all stuff from today. I can click and open up one of these little events and see all of the relevant details. In this case, it's what, a campaign, a source, a medium, and something I can't read. So all the details, all the context around that event is stored right there. If I click on one of those things, it's a drill-through interface, so it'll actually start building a filter programmatically as I explore the data. If I want to, I can take that click-through context that I've just created and save it as a cohort, which is a term that I wish I'd invented. Basically, a cohort is a group of people who share a similar characteristic or set of behaviors. So in the case of LEVIATHAN, cohort membership relates back to an individual user, a customer, a lead, a salesperson, or even an article of clothing. All those can be actors in the system that have events associated with them. And we store them as cohorts basically not by creating a fixed relation saying you belong to this cohort. Rather, we store the recipe instead of the cake. We store the actual query that's used to find all of the actors within the cohort, store that in the database, and anytime you look at it, it's always up to date. Our cohorts are grouped, so we have some that are custom. We have some that are monthly, people who signed up in November, people who signed up in December. Some of them are based on what pay-per-click campaign they came from, and some of them you can just define on your own. You can select 2 or more of them and compare them. Notice there are no gauges, there are no graphs, there are no pie charts. Humans are horrible at geometry. This is just a column of numbers side by side so you can actually compare values and not have to do any sort of weird geometry in your head to figure out what the data is trying to tell you. You can, of course, export it to Excel because that's what people want. And you can also drill into a given cohort and see lots of stats about it. And if you notice down here at the bottom, sort of peeking up below, above the fold, there's a lead. We don't know his name yet, but we have his email address and we know when he signed up. What we could actually do is click on that guy. This is a different guy. Pretend it's the same guy. Now we have Keith Terry. I can see every single event related to Keith Terry. This is stuff that he's done, stuff that's been done to him. He signed up. He was assigned to a stylist. That's not an event that he saw. And in terms of his state in the database, his user record, we don't have a sign-up date stored necessarily, but we know all of these events, all of these transactions around him, all of the history. Yesterday we heard about how history is important information and you shouldn't throw it away. The metaphor was Git, and how Git preserves history, and that's valuable information, provides you valuable context. I like to think that a streaming event database provides some of that context as well. You have your transactional store, which tells you the current state of an object. Unless you have a transaction log, which is going to get to be 250 million lines long and no one's ever going to look at, having an event database to tell you all the interactions in a way that you can actually use that information, in my opinion, is pretty useful. Once you have all of this sort of data collected and you start building tools around how to visualize it, you find that individual stakeholders have very, very different needs in terms of what sort of questions you're trying to get answers to on a daily basis, how they want to ask those questions, and how they want the answers presented to them. So what we've ended up doing is building a lot of what we call micro apps. Basically, for a single stakeholder group, we figure out what are the questions they're asking, what's the best way to answer that with data, what's the best way to tell a story, and we build an app for it. We can spin them up really, really quickly and easily. First one I want to talk about is LEADERBOARD. This was a hack day project. Every 6 weeks at Trunk Club, we have a hack day. Hack day is democratic. You vote with your feet. Everyone comes to the table with an idea. If you say, I want to do a leaderboard, it's going to work like this. Everyone presents their idea. And then everyone who presented an idea goes and stands in one portion of the room. Whoever's interested in that idea comes over and stands with that person. That forms a team. That team goes off, and you have 8 hours in competition with the other teams to build something cool that works, that at 5 o'clock, you're going to show to the stakeholders. It's really, really fun. It's really, really cool. And I'm not just saying that because my team wins every single time. So LEADERBOARD was my first hack day project. We basically wanted to take data that we had in Leviathan, the streaming event data. We have this report that goes out Monday of every week. It's one of those email reports that you delete. It's just like a chore of your existence working for a company. It's the crap you have to delete every single day. No one ever looks at it. It's the sales data from last week. Somebody cares about it. Someone out there does care about it. Someone actually does read it. Someone asked for it. But it's kind of useless because what happened last week is no longer relevant to what I have to do this week. So we wanted to take the streaming event data that we had and give the sales force real-time sales performance data. We wanted to up the ante a bit by putting it prominently on display on a giant plasma screen in the sales area. Because for salespeople, competition is really, really fun and really, really cool. And they like metrics. They like to know that they are doing better than that person and they have to aspire to be as good as this person over here. That sort of drives a salesperson. That's built into their psychology. So we actually worked with several people from the sales team to say, what do you want to see? What do you want to know? How frequently do you want to know it? They said, we want to know it immediately. What's going on? So we built this. This was a little backbone app. All it did was call out to Leviathan, and we had an API built in Leviathan using Faceted, which is a great gem you should check out. And we built this. We have photos of all of our staff on file already. So we just went to AWS or went to Amazon S3 and grabbed their photo. We built a little bar graph that says how much have you shipped this year, this month, this week. How many of your trunks have come back? Because that's expensive for us. That's kind of like a ding. What's the keep rate? How many total transactions have you engaged in? These are the 4 questions that you need questions to, or 5 questions that you need answers to. How is an individual doing, and how is everybody doing relative to one another? So we built this in 8 hours, and we won our hack day. And our salespeople are highly motivated, and instead of getting that emailed report once a week anymore, they look up from their desks. They're like, I'm gonna get her. And they go faster. Hack Day project the second was something called product informant. We pay a lot of attention to our sales force because they are the ones who are actually generating revenue for our company. One of the red-headed stepchildren of our company is the merchandising group, which is responsible for figuring out what expensive clothing we're going to buy and sell to our customers now. And they have no data to work with, none whatsoever. All of their work was on paper and in Excel. So we were like, well, we have all this data now about what's being shipped and what's being returned and why. So we have inventory performance data that's latent in our system. That data is not easy to get to. It's not stored in one place. We don't have statistics about a pair of pants and how well it's doing. It's spread out across thousands of transactions across our data store. But by adopting that streaming ETL process that I talked about and adopting the event-based models, we're actually able to extract that data and present it everything you wanted to know about a pair of pants. And there was like crazy stuff that I'd never even heard of. But what are the sizes it's available in? What are the colors it's available in? Okay, that's standard inventory sort of stuff. What's our margin? Well, that's a little more interesting. How many do we sell? How many of them are sold in-house? How many of them do we ship out? It's all good stuff to know. What's the keep rate? If the keep rate is low, that means lots of people have returned it for some reason. There's something fundamentally wrong with it. How does that keep rate compare to other pairs of jeans? That's important to know. Maybe people always return jeans because jeans are hard to fit. So I want to know the relative return rate. And is it a problem with this vendor or is it a problem with this product? So what's the vendor average? And we can go one step further and we can create crazy metrics that actually have some meaning and some value and take a whole bunch of facts and boil it down into one little progress bar. What's the trunkability of this pair of pants? How good is it going to be when I ship it out to a customer? That's a combination of the profit margin, the keep rate, and how much of the feedback on the item is positive or negative. We even have a cute little icon on the left, thumbs up. Most of the feedback is not negative. We list out what the positive feedback was, what the negative feedback was, collect it all into one little page so the inventory people can go and look and say, do I want to buy that pair of pants for the company again? That's cool. This was an underserved group that in 8 hours got a tool that lets them make decisions on a daily basis that influence how well the companies I work for is going to do. It's pretty awesome to be able to use Ruby and Mongo and easily accessible tools that we use every single day and answer questions like that and actually make a difference in the way the business operates. And once you have the fundamental infrastructure in place, it's really not hard. So summing up, real-time data is valuable. It's also possible to get to it. Step out of your relational thinking, think about statistics, think about events, think about flattening data, think about extracting information into facts and saving the facts. Think about saving the recipe, not just the cake. Relational stuff is great. It's not the only model. Use the technologies you're familiar with, maybe not the tools you're most familiar with, but take the tools and technologies you're used to and use them in new and novel ways. Wrap your data in easy-to-use APIs because you cannot predict how your data wants to be used. Build micro apps to deliver stakeholder dashboards. Be agile, don't be enterprising. I'm Corey at trunkclub.com. I'm Bantic on Twitter. I'm Bantic on GitHub. If you go to trunkclub.com/Corey and sign up to become a customer of Trunk Club, I will give you $50 off your expensive trunk. It's worth it. Trust me, it's good stuff. If you're ever in Chicago, we have co-working space. We also have a 40-foot bar with 4 beers on tap, whiskey, wine, and gin. And we would love to have you come out and drink with us on a Friday and talk to us. I'm humbled to be in the company of so many wonderful Rubyists. I've learned a ton from everybody. I'm thankful for the opportunity that I've had to share some of the things that I've learned on my journey with all of you. I'm eternally grateful to the organizers, and thank you all so much. If there's any questions, I'm happy to answer them.